Hey guys, so this is our last lesson in this unit, and it's right angle trigonometry. So we'll just be looking at right triangle trigonometry, and looking at right triangles and how to solve for different sides in right triangles using some of the knowledge that we've seen from the common triangles, the 45-degree triangle and the 30-degree triangle. So imagine you have a triangle whose side A is opposite angle, not angel. Side B is opposite angle B, and side C is the hypotenuse. So in that triangle, and it's a right angle triangle, let's just right angle triangle, oh, right angle triangle. Where is it? There we go. Right angle triangle. Here we go. So cos B is 4/5, A is 10, and C is the hypotenuse. This is C. If I call this my A, then this side is 10, and if I call if this is B, then the cosine of B is 4/5. They want me to find the sides A, B, and C. Now, seeing that the cosine of B is 4/5, side C is unknown and side A is known to be 10. So we know that from Pythagoras, A squared plus B squared is equal to C squared, right? And we know from SOHCAHTOA that the cosine of B will be equal to adjacent divided by hypotenuse. So the cosine of B is known as 4/5. It's been given. Now don't let this lead you into thinking that the adjacent is automatically 4 and the hypotenuse is automatically 5. We don't know that, because this could be a reduced form of that ratio. So let's not jump to conclusions. The adjacent for now, as we know, is 10, because if you look at this triangle, the adjacent to B is 10, and the hypotenuse is C. So from this fraction, if I cross multiply from this equation, I will end up with C is equal to 5 times 10, or basically 4C is equal to 5 times 10, which is 50. If I divide both sides by 4, I'll end up with C is equal to 12.5. So C is 12.5. I found that, 12.5. Next thing I can find, if I know C is 12.5, I know A is 10. I can use the sine of this angle. Sorry, I can use Pythagoras to find the side B. So A squared, which is 10 squared. Now substituting what I have into Pythagoras, A squared is 10 squared. B squared is I don't know what B is equal to C squared, which is 12.5 squared. When I do Pythagoras, I'll end up finding that B, let me do it down here where I have space. So this is 100 plus B squared is equal to 12.5 squared is calculator is 150 something, 140, 12.5 squared, 156.25. So that means B squared will be equal to 156.25. I'm going to subtract 100 from both sides. Minus 100 is 56.25. And therefore, if I take square root of both sides, I end up getting that the value of B is 7.5. I found B, I found A, and I found B and C, and A was already given. This is how I can use what I know to find what I don't know in a right triangle. Another approach we can take is, especially if we've been given common angles, like 45. I hope you remember that from a 45-degree triangle, a 45-degree right triangle. Yes, 45-degree right triangle, like this, right? From a 45-degree right triangle, the sides are 1 unit, right? And this is square root of 2 units. Now I'm going to do some comparison. This side 1 unit, let me just consider that as the S, the side of the leg of the triangle, and this is also S of the triangle. When you look at this, it's as if S has been multiplied by root 2. So basically 1 times root 2, which I can say is S square root of 2, right? S square root of 2. What I'm just trying to show you is that in a 45-degree triangle, the sides are in the ratios 1, 1, and root 2, which you can think of as S, S, and S root 2, because S can be anything. S can be 10, 10, and then 10 root 2. It can be 50, 50, and then 50 root 2. As long as these sides are equal, then whatever they are will be multiplied by root 2 to get the hypotenuse. So this is the knowledge or the idea I'm going to use to solve this question. Is there a longer way you can use to solve it? Yes. So this is 12, has been given as 12. This has been given as 45 degrees. Angle A is 45 degrees. So this is side C, angle C, and this is angle B. This is side B and side A, right? But remember, I know that for a 45-degree triangle, it's S, S, and root 2, or S root 2. So I know that, I don't know what the sides are, right? I don't know what the sides are, but I know that their ratio is, for a 45-degree triangle, it should be side, side, and then this side times root 2. So this hypotenuse, which is supposed to be side times root 2, it's been given as 12. Now I can use this idea to find what the side should be. So if I divide by root 2, it easily gives me what the side should be. So I have S is equal to 12 divided by root 2, which, remember, we want to take out the radical from the denominator, so that will be 12 root 2 divided by 2. 12 divided by 2 gives you 6. So the side is 6 square root of 2. 6 square root of 2. That means this side has to be, because this is also S, so it has to be 6 square root of 2. And this is also S, so it has to be 6 square root of 2. This is just a short way using knowledge that you know from a 45-degree triangle. So A will be 6 square root of 2, B will also be 6 square root of 2, and C will be 12 because that was already given. I know some of you might want to see if there's an alternative. I'll show you the alternative. So in a 45-degree triangle, again, our same 45-degree triangle, what happened? Shape recognition. Okay, I'm trying to draw a triangle. There we go. In this 45-degree triangle, I've been given that this is 12, this is 45, and I want to find the sides. A and B. Now you can go the long way. You can say sine of 45 is equal to A divided by 12, right? So therefore that means that A is 12 times sine 45, 12 times sine 45. But because you guys know trigonometry, you remember that sine 45 is the same as root 2 divided by 2. So you can see that side A is, if I reduce this by that 6, so I have 6 square root of 2. So side A is 6 square root of 2, which is the same answer that we got on the previous screen. I can do the same thing to get B, because I know that the cosine of A will be equal to B divided by a hypotenuse, which is 12. The cosine of 45 is equal to B over 12. So that means that B alone is 12 cosine 45. And again, you guys remember that the cosine of 45 is root 2 divided by 2. Do the simplifying, and then you'll find that it's the same thing, 6 square root of 2. So yeah, just pick which one is easier for you and then use that. So for the unknown sides of the given triangle. In this triangle, it's a 60-degree triangle. I hope you can see that. It's a 60-degree triangle. And going with the idea that I started with at the beginning, going with that idea, in a 60-degree triangle, if I cut this in half, then this height is square root of 3. This angle is 60 degrees. This side is 1 and this side is 2, right? In that triangle, the sides, you can think of them as being in the relation, or not ratio, in the relation s, right? 2s, and this is root 3s. So basically, the height is s multiplied by root 3. The base is s multiplied by 1, and the hypotenuse is s multiplied by 2. So in this triangle that we've been given the height. I hope you can see that this is the height, the side opposite to the 10. The height, the side that's opposite 60 is s multiplied by root 3. So I know that s multiplied by root 3 must equal 10 in this triangle. And since s root 3 is equal to 10, if I divide by root 3 and divide by root 3, I'll have s is equal to 10 divided by root 3, which if I do the simplifying will be 10 root 3 divided by 3. So this is the relation for the side s. Since I know that side s, the hypotenuse, which is c, must just be 2 times s, which will be 2 times s, which is 10 root 3 divided by 3, which will end up being 20 root 3 divided by 3. And the base a is just s. The base a is just s. So a is 10 root 3 and c is 20 root 3 divided by 3. Is there another way to do it? Yes, there is another way to do it. Still with a 60-degree triangle. No, it's a 45. It's a right angle triangle. The one that's given is a right angle triangle in which this is 60 degrees. The opposite side is 10, and the adjacent is A. So this is B is 10, right? Yeah, and C is unknown. So you can go back to SOHCAHTOA. The sine of 60 is equal to this side, the opposite side, which is 10, divided by the hypotenuse, which is C. You guys remember from your trig that sine of 60 is root 3 divided by 2, and that is equal to 10 divided by C. If I cross multiply here, I'll end up with C root 3 is equal to 20. So therefore, C is equal to 20 divided by root 3. But since I don't want a radical in the denominator, I will simplify this to be 20 root 3 divided by 3, which is the value of C, which is the same as what I have beside. So let's see. And A, I can use cosine, because cosine of 60 will be equal to, or in this case I can use tan. Honestly, I can use tan. I can use tan or cosine. If I use tan, the tan of 60 will be equal to 10 divided by A, right? So, and I hope you guys remember that tan of 60 was the same thing as root 3 is equal to 10 divided by A. So if I cross multiply, I have A root 3 is equal to 10. So therefore, divided by root 3 divided by root 3, A is equal to 10 out of root 3. And if I simplify, multiply by root 3, multiply by root 3, I end up with A is equal to 10 root 3 out of 3, which is the same thing as I had this side. So again, decide which method is easier for you, and that's what you should follow to do your homework. Use a calculator to find the length of each side to 4 decimal places. I have an angle of 81 degrees, an adjacent of 6.5. This is the adjacent. This is the opposite. This is the hypotenuse. So B and C, or the opposite and hypotenuse, are unknown. So I can use tan to find the opposite. Tan of 81 degrees will be equal to opposite over 16.5, which is adjacent. Tan of 81, use your calculator, write 4 decimal places. Opposite is B, which you're looking for, divided by 16.5. When you find what that is, you can cross multiply and find the value of B. I think you'll find that B is 104.1769. I can also use cosine to find the hypotenuse. Cosine of 81 is equal to adjacent, which is 16.5, divided by hypotenuse, which is C. Again, cross multiply. C is equal to 16.5 divided by cosine of 81. You can take this one as slowly as you like, but I'm very confident that you are able to complete it. And you'll find that C is 105.4 something. To 4 decimal places, so that's 105.4755. Yeah. In trigonometry, there's something called elevation and depression, and this is not the first time that you've encountered angles of elevation and angles of depression. The angle of depression is the angle through which you look down to something, right? So depression is always looking down, and elevation is looking up. Since they are alternating angles, the angle of elevation for the same point, and I need to clarify this, for the same point, the angle of elevation is equal to the angle of depression. What I mean is, if someone is flying above you in a helicopter and is standing somewhere here, the angle through which you raise your eyes from your plane to look at the helicopter that is above you, right? The angle through which you raise your eyes to look at the helicopter that's above you, this is the helicopter over here, is the same angle through which someone on the helicopter lowers their eyes or their head to look at you. So if it's for the same reference point, then the angle of elevation is the same as the angle of depression. Let's look at an example. There's a radio tower that's 400 feet from a building. So imagine a building and a radio tower. So this is my building, very tall building, and a radio tower somewhere here. Tower, so tower is something like this, I think. It's not bigger than the building, so smaller than the building, but it's still a tower. Interesting. That's my tower. Okay, too much time spent drawing tower. What do we know? From a window in the building, so there's a certain window in the building here. Some guy in the building determines that the angle of elevation to the top, so the angle of elevation to the top of that tower is 36 degrees, right? And the angle of depression to the bottom of that tower, the angle of depression to the bottom is 23 degrees. How tall is the tower? So we know that this tower is 400 feet from the building. The tallness or the height of the tower is this height here plus this height. So I can call this h1 and this h2, and then I can use tan to find each of the h values. So in the top triangle, and like I said earlier, if it is the same point, the angle of elevation is the same as the angle of depression. But I hope you can see that the angle of elevation to the top and the angle of depression to the bottom are talking about two different things. That's why the angles are not the same. So if I want to find h1, I know that tan of 36 is equal to h1 divided by 400. This can give me h1. And if I want to find h2, I know that tan of 23 equals h2 divided by 400. From the first equation, h1 equals 400 tan 36, and from the second equation, h2 equals 400 tan 23. So to find the total height of the building, I'll just add h1 plus h2, which when you do, I think you'll find that it's 460 point something feet. Alright, that was it. This is your homework. Enjoy.